Hello students, in this video we'll see an example of how to find the present value of an annuity whose payment stream is linearly decreasing. So if we're given a stream of payments of the form, let's draw our number line, our timeline. Here's 0, 1, 2, 3, n minus 1, and n. And so what payments are we going to get here? Typically with an annuity, we think, or annuity meeting, we think of getting $1 here, $1 here, $1 here, $1 here, $1 here. Instead, what we'll do is we will linearly decrease this. We'll have an n over here with n dollars at time 1. We'll get n minus $1 at time 2, n minus $2 at time 3, all the way down to time n when you get $1. So you start up with getting n dollars, and you decrease linearly, you depreciate linearly all the way down to 1. So this is a very sort of, it looks maybe a little bit strange, but it's actually fairly common. There are lots of types of payment mechanisms that give you a lot of money initially and might taper off linearly later on, like a depreciation schedule for certain tax benefits, or in particular, if you have some sort of long-term annuity where you want to get money right when you allow money right when you retire, and then that amount of money goes down as you get older and older and older. So these decreasing annuities are actually fairly common. So I like to find the present value of this stream. So the present value of this stream, the present value, is denoted DA for decreasing annuity with term N and effective annual interest rate I. So we like to find the formula for that. What will DNI be? DANI is going to be N times nu plus N minus 1 nu squared plus N minus 2 nu cubed, all the way down at time N minus 1, I'm going to get $2 at time N minus 1 and $1 at time N. That's our stream of payments, and I'd like to find a formula for this instead of just leaving it in this closed sum form. So we're going to do the same trick we do with the increasing annuities. I'm going to find a formula for 1 plus I times DANI. Every time I hit a nu with a 1 plus I, it lowers the power of nu by 1. So this will turn into an N, because this nu over here will be annihilated by the 1 plus I. Then I'll have an N minus 1 nu. Then over here, I will have a N minus 2 nu squared, all the way down to over here. If I hit nu to the N with I, I'm going to have a 2 nu to the N minus 2. And then this will be a 1 nu to the N minus 1. Okay? Now what I'm going to do is I'm going to take these two representations and subtract them. So if I take this thing over here, this 1 plus I, DANI, and subtract off this, what will be the result? Well, they both have a DANI, and so I'll be left with just an I, DANI. And so what will this give me? Let's check. So what will be left over? So if I subtract this, there's nothing to subtract off the N, so I'm going to have an N. Then I'm going to have a nu N minus 1 minus this thing, so I'll get a cumulative factor of a negative nu from that procedure. If I do this minus this over here, I'll get a cumulative factor of negative nu squared from that factor. If I keep doing this procedure, I'm going to go all the way down over, let's look at this last term over here. If I do this last term over here minus this term over here, those are of the same form. Everything's just been shifted over by 1. I'm going to have a cumulative factor of negative, 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 negative nu to the N minus 1. And then there's this extra negative nu to the N over here. Negative nu to the N that's left over. Great. Now I can write this as N minus nu plus nu squared plus all the way down to nu to the power N. And we can recognize exactly what that is. That's the present value of a traditional annuity immediate. So this thing over here is exactly just ANI. So now, by dividing by I, we have our formula. Our formula, therefore, is that the present value of a decreasing annuity with linearly decreasing payments, NI, is going to be equal to N minus ANI divided by I. We can do the same exact procedure, and you can guess what the formula would be for decreasing annuity due, right? So the same argument will work. Everything's going to be shifted over by one element direction. So that's a good exercise for you all to do, is to do the same procedure over here, except with it, instead of doing a stream of present value of annuity immediate, so these of course are immediates, run the same argument, see if you can generate the same arguments using annuity dues. Thank you very much.